Hi guys, it's clip 670 and 671. So the first one, clip 670, is called systematic listing. So systematic just means that you're doing things following a system, so a logical order. So this is just a way of logically listing different combinations. So the key word here is combinations. So it's how many different ways you can have whatever you're given in a question. So numbers it could be different meals, it could be colours. So for example, if you've got starter, mains and desserts, how many different combinations of meals could you have from, say, 5 starters, 2 mains and 2 desserts? So that's what we're going to look at. So the first one, the clip 670 on systematic listing, this is about listing the numbers. And then when we go on to 671, that's using a method at GCSE that you would use rather than just writing all the combinations out. Okay, so first question is, list all the 4-digit even numbers that can be created using 1, 2, 3, 6. So first thing, 4 digits, they're all even, and it's those 4 numbers. So let's think about what numbers you can actually write down. So start with the 1. So systematic listing means I'm going to start in some way. I'm going to start with 1 in the first one, 2 in the second one, 3 in the third, and 6 in the fourth. And then what other combinations have you got of those numbers? So if I swapped one of these round, I'm going to leave the first 2 the same, because this is for all the 1s. I'll leave the 2s the same. So then I'll just move these round 6 to 3. Then if I leave the 1, I could change to a 3, and I could have 1, 3. I could have 6, 2, couldn't I? But I could also have 2, 6. So 2, 6 and 6, 2. And then 1 stays the same. The other number I've got left is 6. And then I could have 2, 3, and I could have 3, 2. Now, is there any more I can put in that second digit? No, that's it. So out of all the 1s to start with, there are 6 different ways. Now, I've not answered the question yet. We're just doing listing the numbers. So if it's for the 2, we'll start with 2. I could go 1, 3, 6. Go 2, 1, 6, 3. 2. Then I'll do the 3. So I could do 3, 1, 6. And I could do 2, 3, 6, 1. Then finally 2, 6. I could have 2, 6, 1, 3. And 2, 6, 3, 1. So again, 1, 2, 3, 4, there's 6 there again. So notice there's a pattern. Because we're doing it systematically, from this first one we worked out there's 6 for each one. 3. So let's start with 3, then in numerical order. 1, 2, 6, 3, 1, 6, 2. Then use the 2, 3, 2, 1, 6, and 3, 2, 6, 1. And then the 6, 3, 6, 1, 2, 3, 6, 2, 1. And finally, number 6. So start with 6, 6, 1, 2, 3, 6, 1, 3, 2. 6, 2, 3, 1, 6, 2, 1, 3. I've done it the way around. And then finally 6, 3, 1, 2, and 6, 3, 2, 1. Right, so none of them should be duplicated. So there are 24 different ways. So a quick way to check how many ways are there of putting a number in the first one. Well, there's 4 different ways. If I use that number, how many ways are there putting a number in that second column? Well, that's 3 ways. And then the third one, well, I've got 2 numbers left. So there's 2 different numbers I can put in there. And finally, there's only 1 number I can put in there. So notice the first digit, there's 4 different ways you can put them in. So what do you do to them to get 24? Well, the quick way is if you times those together. and that would make 24. Now the question says even numbers. So let's go down and find the even numbers. Now you might be able to go from 24, go, right, I know what they are, or how many there should be. It should be, theoretically, half of them should be even numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they're the 12 even numbers that you would write down in the list. I know that's quite a long-winded way, but I did that so you could see how you would get all the combinations, how you would use the quick way, which is what's going to link to the next question. So that is just for 670, which is systematic listing. That may take you a while to do because there's quite a lot of things you've got to think about and try and work out the different ways. Right, 671. So for product rule, we know product means times. So this is where the actual topic is called product rule for counting. So product means times. So let's say, for example, there are two things, M and N. How many different ways are there of having M and N together? So what the product rule says is that you would just multiply those two together. So for example, if I said there was 2 different types of t-shirt and 7 different pairs of shorts, how many outfits could I make? Now you could go through like this part and do systematic listing and write down all the different combinations. So t-shirt 1 and pair of shorts 1, t-shirt 1, pair of shorts 2, and so on. But a quick way of doing it, like we've gone up here, is that there are 2 times 7 different combinations. That's using this rule. That means there are 14 different ways. Okay, so that's the number of combinations you could have where you've got 2 of one thing and 7 of the other. So think about it. For every one of these t-shirts, there's 7 different pairs of shorts you could match with. So there's 2 sets of t-shirts. You can have 7 for the first t-shirt, 7 for the second. You add them, you get 14. That's where this comes from. So all the questions in clip 671 and 672 and 673 are just extending the use of the product rule. So question 2. If I have 9 different jumpers, 6 different pairs of jeans, and 5 different pairs of socks and 1 pair of shoes, how many different outfits can I have? Now it's stepped up a little bit already. If I just have those two, 9 different jumpers and 6 different jeans, then I would do 9 times 6. But I've also got 5 different pairs of socks, and I've got one pair of shoes. And if that was 2, I'd times by 2. So you would just do 9 times 6 times 5 times 1. So let's find a quick way. So 9 6s are 54. That's 54. 5 times 1 is 5. What's a quick way of doing 54 times 5? Well, I times by 10 divided by 2. So times by 10 is 540. Divided by 2 is 270 different combinations, different outfits. Next one. There's 3 starters, 2 mains and 4 dessert choices. How many different combinations of 3-course meals can you have? Well, there's 3 for the first one, there's 2 for the second one, and there's 4 for the third one. Just double check it is always about all 3 together. So 3 times 2 times 4, 3 2s are 6, 6 4s are 24. So it's 24 different 3-course meals. Next one. How many different 4-digit PIN codes can I have using the digits 0 to 9? Okay, so there are 4 digits. You know that each of these can be between 0 and 9. How many different combinations, how many different numbers could you put into there? So in other words, 0 to 9 is how many different numbers? Well, it's 10. 10 numbers could go there. How many could go there? Well, again, 0 to 9, 10 different ways. There's 10 different choices, and there's another 10 different choices. So because it's a product rule, you find a number of combinations of something, you would times those together. So 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000 different combinations. So if you think in real life, when you have a 4-digit PIN number to get money out of the bank, or if you're going to buy something in the shop, your PIN number is one out of 10,000 different numbers that are possible. Okay, next one. So a little bit advanced. How many PIN numbers starting with 4, with 3 digits, and that are even? Right, so it's a 4-digit PIN number. Sorry, 3-digit number. So 1, 2, 3. How many different choices have you got for the first one? Well, it tells you it's starting with 4, so there's only one different way. It can only be 4. How many can there be for the middle one? Well, it says it's even. What makes it even? Well, that has to be 0, 2, 4, 6, and 8. So there's 5 different possibilities. Now, does that apply to there? No, it's to make it even, it's got to be the end number. So there's 5 different ways there. So what could the middle number be? Well, it can be 0 to 9, can't it? Because it's a PIN number. So that would be 10 different ways. So 1 times 10 times 5. Well, that's easy. 50 different PIN numbers. And number 6. How many different 4-digit PIN numbers? So 4 this time. 1, 2, 3, 4. Could I have where only the digits 2, 3, 4, 6, 7, 8, and 9 can be used and only once? So if I take the first number, how many different possibilities are there? Well, there's 1, 2, 3, 4, 5, 6. There's 7 numbers there. So there's 7 possibilities of that number. Now if you can only use it once, that means once you've used one of them, I've only got 6 left. So for the second number, I've got 6 left. The third number, well, if I've used 2 of those numbers, so let's say I've used the first 2 there, then I've got 5 more left. And then the last one, if I've used 3 of the numbers, I've got 4 left. So using the product rule, you would times those together. So do 7 times 6 times 5 times 4. Well, 7 6s are 42 and 5 4s are 20. So times it by 2 is 84, and then I put a 0 on the end, is 840 combinations. Okay, now you can try the questions which are similar to that, that's on Haggerty Maths.